start solving the problems. Circles sheet 1. Circles sheet 1. I hope you have a copy of this sheet. All right, so problem 1, the center of the circle passing through 0, 0, A0 and 0B. Okay, so we need, yes, of course, yes, if this is 90 degrees, then this must be the diameter of the required circle, and the midpoint of this would be the center of the circle, and the midpoint of this is A by 2 comma B by 2. That's the center of the circle, right? If you have to find the equation of the circle, I hope all of you realize that the circle will have AB the diameter, because this is 90 degrees angle in a semicircle, right? And the equation of the circle with AB the diameter is going to be x minus A into x minus 0 plus y minus B into y minus 0 equal to 0. That would be the equation of the circle passing through 3 points. Is that all right? Right? X minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0, right? The circle x square plus y squared plus 4x minus 7y plus 12 equal to 0. We want to find the length of the intercept made on the y-axis by the circle. Now if you have to find the intersection with the y-axis, you will put x equal to 0. So if you plug in x equal to 0, then you get y squared minus 7y plus 12 equal to 0, giving me y minus 4 into y minus 3 equal to 0, giving me y equal to 3 or 4. That means on the y-axis, the circle passes through 2 points, 0, 3, 0, 4. And therefore, the intercept made on the y-axis would be 1 unit. Is that all right? In problem 3, we have a circle x square plus y squared equal to a squared, and we have a line y equal to mx plus c. Y minus mx minus c equal to 0 is a line, and we want this line to cut the circle at 2 real points A and B. That's what we are looking at. We want this line to cut the circle at 2 real points. That means what we are seeking is that the distance of the circle from the center must be less than the radius. If this distance from the center of the circle is 0, 0, if this is less than the radius, then this line would cut the circle at 2 real and distinct points. So how do you find D? Distance of 0, 0 from this line? Put x equal to 0, y equal to 0, take modulus, divide by root 1 plus m squared, right? So in which case, if you put x equal to 0, y equal to 0 and divide by root 1 plus m squared, you get D, the distance of 0, 0 from this line, and that must be less than the radius. What's the radius of the circle? A units, right? So the required condition is mod c less than a root 1 plus m squared. Mod c, mod minus c is the same as mod c, less than a root 1 plus m squared. That's a required condition for this line to intersect the circle at 2 real and distinct points. Is that okay? Now we have a circle x squared plus y squared plus 3x minus 6y minus 9 equal to 0 is a given circle. This is the circle. What's the center of the circle? Minus 3 by 2 comma 3 is the center of the circle, right? What's the radius of the circle? whole squared plus 3 squared plus 9. That's the radius of the circle, right? How much is it? 9 by 2. Okay, so this is 9 by 2 is the radius of the circle, right? Now we have another circle that rolls over the surface of this circle. Another circle that rolls over the surface of the circle. And the radius of the circle is given to be 2 units. The radius of the circle is given to be 2 units. Radius of this circle is r units, where r is 9 by 2, right? Now if therefore while this circle rolls over the circle, the center of this circle undertakes a circular trajectory. The center of the rolling circle takes up a circular trajectory, right? Which means the distance of the center of the circle from the center of the circle must be equal to r plus 2, right? That means square of the distance, which is like h plus 3 by 2 whole squared plus k minus 3 whole squared, that must be 2 plus 9 by 2 whole squared, right? And then what you do is go ahead and generalize, replace h by x and k by y to get the locus of the center of the circle. So which means x plus 3 by 2 whole squared plus y minus 3 whole squared is 13 by 2 whole squared. That's the locus of the center of the circle that rolls over the first circle. Is that okay? The circle described on the line joining the points. So problem 5. We have a circle described on the line joining 0, 1, comma AB as the diameter. Okay, so if there is a circle with 0, 1 and AB as the diameter, some point AB as the diameter, say, a circle with this as the diameter, then what's the equation of the circle? Into x minus a plus y minus 1 into y minus b equal to 0 is the equation of the circle with this as the diameter. Now, cut the x-axis in points. Now, to find the intersection of this with the x-axis, what would you do? Put y equal to 0, right? To find the intersection with the x-axis. So, intersection with the x-axis put y equal to 0. So you get x squared minus ax plus b equal to 0. Giving me two values of x, the 2 points of intersection with the x-axis. So it's going to intersect the x-axis at 2 points, x1 and x2. Where x1 and x2 will be the roots of this. x1 and x2 will be the roots of this quadratic in x. Right? Can I wipe this off? Problem 6. We are talking of a circle that passes through 0, 0. Oh, okay. No, it passes through 1, 0. Okay, yes, 0, 0, 1, 0. 0, 1. These are the points through which it passes. And there is another point 2k comma 3k through which the circle passes. Alright. So which means the circle must be like this. This is 90 degrees. This therefore must be the diameter of the circle. And the point 2k comma 3k lies somewhere on the circle. Right? So this must be the diameter. So equation of the circle with this as the diameter is going to be x minus 0 into x minus 1 plus y minus 1 into y minus 0 equal to 0. Is the equation of the circle. But 2k comma 3k is a point on the circle. So put x equal to 2k and y equal to 3k. So 2k into 2k minus 1 plus 3k into 3k minus 1 equal to 0. Now k is not 0. Why is k not 0? Because if k were to be 0, it will be the origin. So k is not 0. So if k is not 0, we must have 2 into 2k minus 1 plus 3 into 3k minus 1 equal to 0, and you can solve for k. Clear? There is a circle S and there is a line drawn through a certain point P, alpha beta, that intersects the circle at A and B. Now we need to find PA into PB. PA into PB is actually PT squared, square of the tangent. A property of the circle, PA into PB is PT squared. So this is PT squared. That means square of the tangent from alpha beta to the circle. How would you obtain? Put x equal to alpha here and y equal to beta. You will get the length of square of the length of the tangent from alpha beta to the circle. So this is going to be alpha squared plus beta squared minus a squared is going to be PA into PB. It's also called the power of the circle with respect to the point P. This PA into PB is also called the power of the circle with respect to the point P. Number 8. Equation of a circle passing through 3 comma minus 6. 3 comma minus 6 is the point in the fourth quadrant and touching both the axes. That means this must be the circle passing through a point P, which is 3 comma minus 6, and touching both the coordinate axes, right? Now, if R is the radius of the circle, then this is R and this is also R. So what are the coordinates of the center? R comma minus R. R comma minus R would be the coordinates of the center of the circle, right? And distance of R comma minus R from 3 comma minus 6 will be equal to R. So this distance, R minus 3 whole square plus R minus 6 whole square minus R plus 6 whole square minus R plus 6 whole square must be equal to R square. And all that you need to do is solve this quadratic. You will get two circles. Two values of R is what you will get. Two values of R is what you will get, causing two circles with this property. Actually, wonder how you get two circles out of this property. Essentially, these two circles pass through 3 comma minus 6 and touch the coordinate axis. This is how it could happen, isn't it? Physically, these are two circles passing through the point 3 comma minus 6 and both touching the coordinate axis. Physically, you can see that there are two such possibilities. There are two such possibilities. That's the reason the mathematics of this gives me two values of R each. Right? Yes or no? R equal to 15 and 3. Okay, R equal to 15 and R equal to 3. So this would be the circle, say R equal to 15, and this would be the circle R equal to 3. No, it is not. Then that equation will give you more than two values of R. Why don't you try and draw more than two circles with this property? Problem 9. We are talking of a circle passing through the point 0, 0, 1, 0 and touching the circle x square plus y squared equal to 9. Now, this is a circle, x square plus y squared equal to 9. What's the center of the circle? 0, 0. The radius of the circle is 3 units. This is the center of the circle. A little badly drawn circle, but the intention was fair. Okay, what is this point? 3, 0. What is this point? Minus 3, 0. Alright. Now the other circle that we are talking of passes through 0, 0, passes through this point, and passes through a point here. 1, 0 is a point inside the circle, right? And touching the circle, therefore, the only possibility is the second circle must be touching the circle internally. Absolutely, internally. This is that circle touching the circle internally, right? Now, this is the diameter of the smaller circle, which must be the radius of the larger circle. This diameter of the smaller circle, therefore, must be the radius of the larger circle, and the radius of the larger circle is 3. So the radius of this circle must be 3 by 2. Radius of this circle must be 3 by 2. Right? Now, what about the center of the circle? See, the center of the circle is this, right? M is the midpoint of this chord, let's say OP. What are the coordinates of M? Half comma 0 will be the coordinates of M, right? Now, see, this is half a unit. This is the radius, OC is the radius of the circle, which is 3 by 2 units. So this CM must be root 9 by 4 minus 1 by 4. That means root 2 units. CM must be root 2 units. Right? That means this circle, this inner circle, has center whose coordinates are half comma root 2. Half comma root 2 would be the coordinates of the center. And the radius of the circle is 3 by 2. So the equation of this circle is going to be x minus half whole squared plus y minus root 2 whole squared equal to r squared. Now, there is another possibility. We could have had this outer circle, and the inner circle could also have been like this, isn't it? This circle could also have been like this. I mean, reflect the circle about this line. No, no, dude, only 2 circles, because you know it has to pass through. Yes, and yes, and the radius of this circle will still be the same, will still be 3 by 2 units. The center of the circle will have half comma minus root 2. The center of the circle will be half comma minus root 2. Right? So the equation of the circle is going to be x minus half whole squared plus y plus root 2 whole squared equal to 3 by 2 whole squared. Clear now? Does it make sense to all of you? Huh? Huh? Yeah, yeah, sure. from the center, if you draw a perpendicular, it will bisect the chord. You learned this in class 2. 3. 7, na? 7, I think they teach you all this. Okay, I'll explain that, not a problem. Let me know if I could wipe this off first. So he's saying, if I have a point P and I draw a second, then PA into PB is PC into PD. Now, triangle PAC and BDP, can you establish similarity of these two triangles? That's all. That's all. Similarity of these two triangles will result in that. And I hope similarity is not difficult. Say, if this angle is alpha, this is pi minus alpha, cyclic quadrilateral, and therefore this will be alpha. If this angle is beta, this will be pi minus beta. Why? Cyclic quadrilateral. This therefore would be beta. And this angle is common to both. Now if you write the condition for similarity of the two triangles, you end up getting that. Right? And then why on earth is it equal to PT squared? Because this also is a secant with points C and D becoming coincident. So then this will be like PT into PT. Two coincident T's. So it will become PT squared. That's how you look at it. Right? Shall we proceed? Number 10. We have a circle x square plus y squared minus 12x plus 4y plus 6 equal to 0. What's the center of the circle? Minus 2. 6 comma minus 2 is the center of the circle. So a diameter will always pass through this point, isn't it? A diameter will always pass through this point. So any diameter passing through 6 comma minus 2 must be like x minus 6 plus lambda into y plus 2 equal to 0, isn't it? No matter what lambda you assign, this will always be a line passing through 6 comma minus 2, isn't it? For different lambdas you get different lines passing through 6 comma minus 2. Therefore this will represent the family of lines passing through the center, and therefore the family of diameters. Therefore the family of diameters, right? If lambda is looked upon as a parameter, right? Equation of the circle with center on the y-axis. On the y-axis, passing through the origin, the center on the y-axis, passing through the origin and the point 2 comma 3. If r is the radius, then C will have coordinates 0 comma r, right? And distance of C from P must be r. This must be r. So if you use that fact, 2 squared plus r minus 3 whole squared is r squared, and you'll get the radius of the circle and therefore also the center of the circle. Shall we move? Problem 14. The equation of the circles which touch both the axis and the line x equal to a. This is one possibility, touching both the coordinates and the line x equal to a, right? One possibility. There could be a similar circle like this also, right? So now for this circle, if r is the radius of this circle, do you realize that this length will be a? So this will be, the center would be a by 2 comma a by 2 would be the center of the circle. The radius of the circle will be a by 2. So the equation of the circle is going to be x minus a by 2 whole squared plus y minus a by 2 whole squared equal to a by 2 whole squared. That's one possibility, right? The other possibility is you could have had a circle like this. Again, the radius of the circle will still be a by 2, but the center of the circle will now be a by 2 comma minus a by 2, and the equation of this circle then is going to be x minus a by 2 whole squared plus y plus a by 2 whole squared equal to a by 2 whole squared. If a circle passes through the points of intersection of the coordinate axis with the lines, this is one line, and you could write this as x by minus 1 by lambda y by 1 equal to 1, yes or no? Transposing minus 1 on the right hand side and dividing by minus 1. The other line is x minus 2y plus 3 equal to 0, which could be written as x by minus 3 y by 3 by 2 equal to 1. That's the other line. Right? Now this circle passes through these points. Intersection of the lines with the coordinate axis. This point is minus 1 by lambda comma 0. This point is 0 comma 1. X and y intercepts, right? How do you think lambda is necessarily positive? I never claimed anything about lambda, right? And minus 3 and 3 by 2. Okay, now what you could do is, for convenience, now you might just want to move this on this side, because then it will make sense drawing the circle. Until then we didn't know it would make sense. Now it would make sense drawing the circle with minus 1 by lambda here and minus 3 comma 0 here, right? So the circle passes through these points A, B, C, D. These are the points through which the circle passes, right? it would be horrendous for me to actually draw the circle here. So what I'll do is I'll first draw the circle and then put the points, if you allow me, right? AB. I mean, I could still have by brute force drawn some circle which would have looked like a figure from Mars. It still doesn't look very good, but you know, it's okay. This is how the circle is, right? Now, very simple, very simple. Do you realize that OC into OD must be OA into OB? What do you say? That's the property we just looked at, right? Now, what's OC? OC is 1. What's OD? 3 by 2. OC is 1. OD is 3 by 2. OA 3. This length 1 by lambda. This length 1 by lambda. Lambda known. That will cause these points to be concyclic then. Yes or no? Right? We couldn't have drawn the circle. Okay, now I recommend, instead of imposing my thoughts, you put this point here, put this point there, and try and draw the circle. You will have a merry-go-round. ABCD is a square whose side is A. ABCD is a square whose side is A. Whose side is A. Equation of the circle circumscribing the square, taking AB and AD as the reference axis. That means taking this as the x-axis, taking this as the y-axis. Right? So then A will be 0, 0, B will be, D will be 0A. So a circle that passes through this will be 90 degrees, angle in a semicircle. So AD must be the diameter of that circle. So the equation of the circle with BD, the diameter, is going to be x minus 0 into plus y minus A into y minus 0 equal to 0 would be the equation of the circle with diameter BD. Yeah, that's not too bad, right? Point P has coordinates x1, y1. Point Q has coordinates x2, y2. PQ is a diameter. PQ is a known diameter, and x1 and x2, the abscissa of P and Q, x1 and x2 are the roots of x squared plus 2ax minus b squared equal to 0. That's given in the problem. x1 and x2 are the roots of this, right? And y1 and y2 are the roots of x squared plus 2px minus q squared equal to 0. In fact, just to make it look a little more graceful, what we could do is, instead of x, I can call it y. How will the roots change? Then y1 and y2 are the roots of this. It doesn't make any difference, isn't it? Now, we want to be able to find the equation of the circle with a diameter PQ. Now, the equation of the circle with diameter PQ is going to be given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0, what will you do? All of you are right, but not efficient. I mean, I know what you're saying. You expand this x square minus x into x1 plus x2, the sum of the roots, plus x1, x2, the product of the roots. Y square minus y, y1 plus y2, the sum of the roots, plus y1, y2, product of the roots. Right, but not good. Reason, I'll tell you very simple. x1 and x2 are the roots of this. That means the two factors of this must be x minus x1 into x minus x2 must be the factors of this. Yes or no? Right? y1 and y2 are the roots of this. So the two, this must be factorizable as y minus y1 into y minus y2, and this must be factorizable as x minus x1 into x minus x2. Finish here. X minus x1 into x minus x2 is actually this, x squared plus 2ax minus b squared, and y minus y1 into y minus y2 is just this, right? Finish. That's the equation of the circle. Khatam khela. No, but that x is only symbolic. Is it not? I mean, I'm not saying it will always work. If it was given y1 squared and y2 cubed are the roots, then of course you will not do this, right? Problem 19. We have a circle x square plus y squared equal to a squared, and we are talking of tangents drawn from P to be mutually perpendicular. That means this P must lie, right, director circle. The director circle will be a circle concentric with this circle, having the same center 0, 0, and the radius of the director circle will be root 2 times the radius of the mother circle. So the equation of the director circle on which P lies is x minus 0 whole squared plus y minus 0 whole squared equal to a root 2 squared. That's the equation of the director circle, therefore the locus of P. What do you say? Right? Now I will continue giving you, see, of course before pujas we will have a bang, but I will continue giving you small kuti tests on topics that I kind of finish, or halfway. Now I have decided also halfway down a topic I want to give you a test, so that you know you come to terms with that topic. By the time the topic finishes, you know you'll have loads of things to do and you may not perform. If I have a test halfway down the topic, then perhaps you'll do better in terms of problem solving in class. You'll do good, because you know a test always forces you to do things in advance and you do them more intensely. If it were not for a test, you would actually not do anything. Just come to the class, listen to my discourses, go back home, chill. So we're talking of two circles. And we want the two circles to intersect at distinct points. Now for two circles to intersect at distinct points, the distance between their centers must be less than the sum of the radii and must be greater than the magnitude of the difference of the radii, isn't it? That's a condition for two circles to intersect at distinct points. Have I told you this? Yes, sir. Okay, thank God. This is a circle with center 1, 3 and radius r. This is a circle with center 4, -1 and radius 15 minus, or is it 15 plus 16 minus 8? 2 root 2? 9. 17 minus 8. 9. 3 units. Radius 3 units. 16 plus 17 minus 1. 3 units is the radius of the circle, right? Now, distance between their centers, C1, C2, right? So, that's going to be 9 plus 16. 5 units is the distance between their centers, right? And that must be less than the sum of the radii, that means r plus 3. Sum of the radii must be greater than the difference of the radii mod of r minus 3. Yes or no? Yes. The distance between their centers. Are you confused? No, yeah, tell me. Distance between their centers, distance formula. No, these are the two circles. These are the two circles. One circle is center 1, 3. The other circle is center C2 4, -1. This is the distance between their centers. The radius of this circle is r. The radius of this circle is 3. For them to intersect at two distinct points, the distance between their centers using distance formula must be less than the sum of the radii, r plus 3, must be greater than the magnitude of the difference of the radii. Right now? So, we end up getting from this r plus 3 greater than 5 or r greater than 2. That's one condition. And along with this, right? So, we get mod of r minus 3 less than 5. Mod of r minus 3 less than 5. This is going to give me r minus 3 less than, greater than minus 5. R minus 3 less than 5 greater than minus 5. Hey, you've forgotten all about modulus. Mod x less than a means x less than a greater than minus a. Yes or no? So, this gives me r less than 8 greater than minus 2. Yes or no? Yes, sir. So, this along with and r greater than 2. So, if I take the intersection of these two regions, I get r greater than 2 less than 8 is what I get, right? If I am seeking an r that satisfies this condition as well as this condition, then I get r greater than 2 but less than 8. So, the required values of r would lie between 2 and 8. Clear, no? So, we have in problem 21, we have a circle like this, x square plus y squared plus 2gx plus 2fy plus c equal to 0. What's the center of the circle? What's the radius of the circle? Right. This is one circle given, right? And there is another circle . This is another circle. What's the center of the circle? Minus g comma minus f. The radius of the circle is What's the C for the circle? These last two terms are the C for this circle, isn't it? So minus C sine squared alpha plus G square plus F squared cos square alpha. Yes or no? R2 then, let's simplify matters here. This G square plus F square and G square plus F square cos square alpha, let me club together. So I end up getting root G square plus F squared into 1 minus cos square alpha, that makes it sine square alpha, very good. Minus C sine square alpha. Which is like root G square plus F squared minus C sine alpha. So R2 is R1 sine alpha. So R2 must be less than R1 because sine alpha is less than 1. R2 must be less than R1, right? So this is the smaller circle, this is the bigger circle. This is the outer circle, this is the inner circle. And do you realize that the two circles are concentric? They have the same center, minus G minus F, right? These are the two circles, concentric. Now, what we are seeking is, from a point on this circle, we are drawing two tangents. And we want to find the angle between the two tangents, right, from a point on the circle. Now, this is theta, this is also theta, this is PC, this is PA, and we end up getting R2 is R1 sine alpha, like we got. R2 is the radius of the inner circle, R1 is the radius of the outer circle. This is R2 and this is R1, right? Do you then realize that sine theta, this is 90 degrees, sine theta is R2 by R1, but R2 by R1 is sine, R2 by R1 is sine alpha. So theta equal to alpha, and this angle between the two tangents must be 2 theta, which is the same as 2 alpha. 2 alpha is the angle between the two tangents. Got it? Didn't understand this, huh? I'm saying 2 theta is the angle between the two tangents. Sine theta is R2 by R1. Hey, but R2 by R1 is sine alpha. We got that now earlier. So R2 by R1 is right as sine alpha. So theta equal to alpha. So 2 theta would be 2 alpha. That's the angle between the two tangents. Have I discussed orthogonality? Yes, sir. Radii at the point of intersection must be perpendicular. That's orthogonality, right? So here we are talking of, in problem 22, a circle like this, another circle, center 0, 0, radius A, which is this circle, radius K, we want to find the locus of the center of this circle. Let's say the center of the circle at some instant is h comma k, right? And this circle passes through a comma b, a point a comma b, right? Now for them to be orthogonal, realize that this k and this r must be perpendicular for orthogonality, right? So then do we have like a r square plus k squared equal to h squared plus k squared? Oh, sorry, let me not mix it up. This is k, so let me call this point say h1 k1. Let me call it h1 k1. See, k is the radius of the circle. I can't call the center of the circle as h comma k. Let me call it h1 k1. So h1 squared plus k1 squared must be r squared plus k squared, right? Hey, but now we need to eliminate r, the radius of this circle. Yes, yes. Now realize that this is also r. So I can replace the r square here by h1 minus a whole square plus k1 minus b whole square. So r gets dispensed away, right? So this r squared I write as h1 minus a whole square plus k1 minus b whole squared as this r squared, right? Plus k squared is h1 squared plus k1 squared. Generalize, absolutely generalizing it. Replace h1 by x and k1 by y to get the locus of the center of the circle, right? So when we generalize, we get like a x minus a whole squared plus y minus b whole squared plus k squared is x squared plus y squared, etc. Bless you. Sounds good? Of course, x square, y square will get cancelled and you will get a linear in x and y. That means the locus of the center is a straight line. The locus of the center will turn out to be a straight line. Right. Can I wipe this off? You want to copy? Done? So in problem 23, see, reason I'm not giving you time is because I'm assuming you would have read through this sheet at least, if not done, right? So if the tangent from P to the circle, this is the circle x square plus y squared equal to 1, is perpendicular to the tangent from P to the circle x square plus y squared equal to 9. This is the circle x square plus y squared equal to 1, and this is the circle x square plus y squared equal to 9. They are concentric circles, one with radius 1, the other one with radius 3. Now what we have is a point from where we are drawing a tangent to this circle. We are drawing a tangent to this circle. We have a point from where we are drawing a tangent to this circle, and we are also drawing a tangent to this circle. We are also drawing a tangent to this circle, and the two tangents are known to be perpendicular to each other. I forced it, yeah. See, this would be a tangent, so this would be perpendicular, so this ought to have constituted a rectangle, isn't it? Since I'm not drawing to scale, I had to, manipulate things and move it here so that this looks like, this ought to have been a rectangle. See, this perpendicular, radius perpendicular, this tangent, so this radius perpendicular. So to force it to look like a rectangle, I deliberately moved the center here. Right. Now what we are seeking is P lies on a circle. So do you realize that this is 1 unit? Right? This is 1 unit, the radius of the smaller circle, and this is 3 units, the radius of the bigger circle. This is 3 units. So then distance of P from the center C of the circle hardly looks like the center, but please, distance of this point P from the center of the circle, PC, would be root 3 squared plus 1 squared. That means P lies on a circle with center C and radius root 10. P lies on a circle with center C and radius root 10. Now this root 10 is neither the arithmetic mean of the two radii nor the geometric mean of the two radii, right? False. Shall we move? Yes, please. Locus of the point P will be a circle of radius root 10 with center 0, 0. No, if you have, see why? Because no matter where P lies, its distance from C will always be root 10. So if P moves in such a manner that its distance from a fixed point C is root 10, then the locus of P must be a circle whose center must be C and radius must be root 10. Clear? Is that okay? Find the locus of the midpoints of the chords of the circle. This is a chord parallel to y equal to mx, means slope m. This circle is x square plus y squared equal to a squared. So we are talking of the midpoint of this, right? We're talking of the midpoint of this. H comma k is the midpoint of this. This is 0, 0. If the slope of this is m, what's the slope of this? Minus 1 by m. And therefore we have k minus 0 by h minus 0 equal to minus 1 by m, right? So we have k equal to minus 1 by m into h. So what would you do next? Generalize, replace k by y and h by x. So the locus of the midpoint would be a straight line passing through the origin and of slope minus 1 by m. That's the locus of capital M. A circle touches a given straight line and cuts off a constant length 2d from a perpendicular line. This is a certain line, the circle is touching this line, and this is a perpendicular line and it cuts a length 2d from this line. This is the circle, right? We want to find the locus of the center of the circle, but before that we need to define our coordinate axis. Hey, you already have a pair of perpendicular lines, might as well call them the coordinate axis, right? Why synthesize another pair for that, right? So call this the x-axis, call this the y-axis. Now this length is given to be 2d. Now if this is the radius r, this is the radius r, then this length will be r, right? This would be d, this would be d, right? The x coordinate of the center would be, x coordinate of the center would be r, say let me call it h, k. The x coordinate of the center is r. The y coordinate of the center would be what? K. Root r squared minus d squared. That's the y coordinate of the center. And what are we seeking to do? We are seeking to connect h and k. We need to eliminate r, right? So this r squared to be replaced by h squared. So we end up getting h squared minus k squared is d squared. That's the algebraic condition observed by the x and y coordinates of the center of the circle, with the two given lines being the reference axis. Perform the last rites on this. Replace h by x and k by y. So then x squared minus y squared is d squared. In class 12, we learned that this actually represents a hyperbola. This is the equation of a hyperbola. The locus of the center then, see, given by x squared minus y squared is actually a hyperbola. We'll learn more about this later, but for the time being, just make a note of it. The locus of the center therefore is a hyperbola. Yes, Prince. See, although passing reference right now, this xy equal to constant is a rectangular hyperbola. You know, you've heard about this in the past, right? Right? This is xy equal to constant. This is a rectangular hyperbola, one kind of a rectangular hyperbola, right? This is another kind of a rectangular hyperbola. Only difference is that it'll look like this. That's why I said don't bother too much about it right now, because Boyle's law is this. The slight departure from Boyle's law. All right, so this was Soil's law. 26. Now what's in a name, Prakhar? Okay. A circle passes through a fixed point A. And cuts two perpendicular straight lines through A in B and C. These are the two perpendicular straight lines, and we can call them the x and the y axis, right? Huh? Yes, tell me. No, no one has given you the origin, so you decide the origin, right? No one gave you the x and the y axis, so decide the x and the y axis, right? It was not God sent. So if it's not God sent, then you decide what it's going to be. Now all that we know here is, it's important to understand this. All that we know here is this fixed point A. This fixed line and fixed line, that's known. However, through the point A, we could draw very many circles with variable B and C. B and C therefore are variables. B and C are variables. We could draw very many circles passing through A, cutting these two perpendicular lines at variable B and C, right? Now, if I had not limited things, then I would have had any wild circle going through. But what's said here very categorically is that only those values of only those positions of B and C would be looked upon as sanguine, in which the variable line BC is the variable line, by the way. The variable line BC passes through a certain fixed point, call it x1, y1. See, essentially what I mean is, I can draw large number of circles passing through A, cutting at different BCs. So for every such circle that I draw, there will be a different BC, but I am going to look upon only those circles in which all the BCs are a bunch of concurrent lines passing through x1, y1. Those would be the circles that I am seeking. Those would be the family of, that would be the family of circles that I am entertaining here. Yes or no? Right? Now, we want to be able to find the locus of the center of such circles. We want to be able to find the locus of the center of all such circles passing through A, cutting these two lines at B and C, where all the BCs produced must necessarily pass through a fixed point x1 comma y1. The center of such circles is what we are seeking. Okay. Now, let's say the center of this circle is h comma k. Eventually, we'll generalize, replace h by x and k by y. Once we connect them, now if this is the center, this must be the diameter at any given instant. Why? Because this is angle in a semicircle, which means B must be 2h0. See, this must be the midpoint of BC. B must be 2h0 and C must be 0, 2k. Yes or no? Right? Now, we want to find the locus of the center. We want to find the locus of the center. What's the equation of this line BC? X by 2h plus y by 2k equal to 1 is the variable BC. Right? But the variable BC, no matter what hk is, must necessarily pass through x1 comma y1. So x1, right, x1 y1 would be a point on this variable C BC for all acceptable positions of B and C, right? So replace x by x1 and y by y1. Hey, but this is true for all HKs, all such centers. So generalize this, replace h by x and k by y to get the locus of the required center, right? So generalize this, you get x1 by 2x plus y1 by 2y equal to 1, where xy represents the locus of the center of O of the circle. Sounds good? Yes, please. No, but shall we move? Huh? No, but I can choose that 0, 0, isn't it? I have chosen this point A as the origin. Can I not choose A as the origin? And if I choose A as the origin, can I then not choose the two lines as the x and the y axis? So you are given a blank piece of paper and you want to script your own story. So do it conveniently, right? So why not choose A as the origin and the two perpendicular lines as the coordinate axis, right? Huh? No, Guru, the equation of the line will give you the equation of the line only. Why would it give you the locus? I'm saying this is the equation of the variable BC. Why is this variable? Because h and k are the variable coordinates of the moving O. Right? But then no matter what hk is, all such BCs, sorry for the terminology, all such BCs will necessarily pass through x1 comma y1. Unintended, it so happened. Okay. Shall we move? If the chord of contact of tangents from P x1 y1 to the circle x square plus y squared equal to a squared touches the circle, so this is the circle, say x square plus y squared equal to a squared, from a point P x1 y1, from a point P x1 y1, if we draw the two tangents to this circle, then this would be the chord of contact. The equation of the chord of contact would be T equal to 0, right? X x1 plus y1 minus a squared equal to 0 would be the equation of the chord of contact, right? And this chord of contact touches this chord of contact, say it touches the circle, touches x minus a whole squared plus y squared equal to a squared. This chord of contact touches the circle. How would a line touch a circle? If the distance of the line from the center is equal to the radius, right? When would this line touch this? If the distance of this line from the center, what's the center of this? A0 is the center. So now what's the distance of this line from A0? Replace x by a, y by 0. Replace x by a, y by 0 and divide by root x1 squared plus y1 squared. That will give me the distance of the center from this line, right? Distance of the center, which is ax1 minus a squared divided by root x1 squared plus y1 squared. That's the distance of the center from this line, and that must be equal to the radius a of the circle for the line to touch the circle. Now locus means generalize this, replace x1 by x and y1 by y. That will give you the locus of all such points. That will give you the locus of all such points. This was the circle x squared plus y squared equal to a squared, right? Now there is a variable point p. P is a moving point and its character is given to us. From all such moving points x1, y1, you consider the chord of contact for those points. The chord of contact for those points will be this. Now, what's given in the problem is that all such chords of contact will touch the circle. When would a line touch a circle? When its distance from the center of the circle must be equal to the radius of the circle. That means distance of this line from A0, which is the center of the circle, must be equal to the radius a of the circle. So what's the distance of A0 from this line? Replace x by a, y by 0, take mod, divide by root x1 squared plus y1 squared, and that must be equal to the radius a of the circle. And then go ahead and generalize, replace x1 by x and y1 by y. You get mod of ax minus a squared that's a required locus. Now let me teach you something.